Hello.
Okay,
Welcome.
Farid,
Yes. Yes.
Farid is online.
Yes. Yes.
Farid,
Felipe. Welcome. Welcome to a new virtual tour of the European Southern Observatory, also known as simply as ESO. My name is Farid Char, and with the producer Felipe Zurita, we will guide you on this journey to ESO's La Silla Observatory. Um, in my case, I am one of the tourist guides of one of the ESO observatories, Paraná Observatory in my case. But I have a lot of experience also in outreach and education, and I work in a center of astronomy for a university in Antofagasta. Today Felipe will be the producer, so he will help me to go on with this tour. And please remember that you can send your questions or comments to this broadcast. I imagine you may have a few questions already. So for this purpose, you can leave your comments or questions in the comments section on Facebook or YouTube. So you can give your name and city, and Felipe will be searching for your questions and
yes,
names and cities.
I will read the questions of the people.
Yeah,
Hello,
yeah, of course.
everyone.
So we will have a good interaction with our public. So Iso would like to join with you join you with this virtual tours and taking astronomy directly to your home or wherever you are. So you can put in the comment section where you are writing from Chile, South America, Europe, etc. So we want to know, of course. Also, please don't forget to share this experience if you enjoy it. So you can share simply using your buttons on Facebook or YouTube. Okay. So now let's start with this experience, with this tour. So let's begin with the European Southern Observatory. I want to let you know more information about this place. So ESO is an intergovernmental organization composed by 16 member states. Okay, its headquarters are in Germany, in Garching, and Australia has recently become a strategic partner. Chile is the host state and home to all ESO's observatories. So since the 60s, with the purpose I mentioned, ESO chose one of the best places on the planet to carry out astronomy, the Atacama Desert in Chile. So at that time, Chile had started a site exploration campaign to attract international observatories such as ESO to our country. So Chile offered land, and ESO chose the area that seemed best. So ESO's mission is to design, build, and operate astronomical observatories. What for? To enable important scientific discoveries, and foster cooperation in astronomy. So this image right now shows ESO's three observing sites in Chile. Okay. So first we have the Paraná Observatory. This observatory is home to the Very Large Telescope, or VLT, currently the most advanced visible light observatory on the planet. In the future, the Paraná Observatory will also host the Extremely Large Telescope, or ELT, which will become the world's largest visible light telescope. And we will also have the CTA, an array of telescopes for the detection of gamma rays. Then we have Shahnan-Tor, the site where the ALMA and APEX radio telescopes are located. ESO participates in these radio astronomical observatories with its international partners. And finally, we have La Silla Observatory, the site you will be visiting today. This was the first observatory built by ESO in Chile, 2,400 meters above sea level, in the region of Coquimbo. So we will go there virtually during the next hour. Okay? So now let's travel to La Silla Observatory.
I will start showing the first part in out of Chile here.
Okay, thank you, Felipe. So, looking at our planet, we start our journey by land in Europe. Since I must mention that ESO it's a European organization. On this map, outlined in white, we can see the different ESO member states. Okay? So Chile is the host country and home to all ESO observatories. To see the sites, we will travel to the Chilean mountain range. As we move over the Atlantic Ocean, let me tell you more about ESO's mission. To give you an idea, ESO tries to devise which type of instruments are needed to study the universe, and then design the pieces, builds and operates telescopes, responding to, observational requests from around the world, thus encouraging cooperation in astronomy. So we are almost there. What an amazing mountain! Can you see a mountain range with domes across? Well, in a few moments, of course, in a few moments, we are going to take a look at the mountain range and you will see some domes. Okay? So you have to take a look at the shape of this hill in a few moments. Um, Now we are almost there, almost there.
Is here.
And okay, yeah. So if you look at this hill, does it remind you of anything? Perhaps a horse saddle? In fact, the mountain itself and the observatory later were named after a saddle for horse riding. So over the years, ESO's La Silla Observatory has become the perfect viewpoint for studying the universe. It was chosen by the astronomical community as an observational site at the beginning of the 60s. So La Silla enjoys a large number of clear nights per year, a still and dry atmosphere, and dark skies, far away from artificial light sources, which exist in cities. The observatory was officially inaugurated by ESO in 1969, and some of the telescopes seen on this picture are now out of service. Currently, 10 telescopes are operating, and 2 are operated directly by ESO. The other telescopes, several of which are robotic, belong to other institutions with ESO providing providing facilities and required support. So to get to know this and more, we will plunge into the observatory. So in order to avoid getting dizzy with cures and counter cures on the road, we will fly there. Okay. So at this point, you can see that La Silla has a lot of telescopes, of course, of various shapes and sizes. Um, and we are going to start this journey visiting the largest telescope. Okay, so we have in this case the ESO's 3.6 meter telescope. Okay, and in the background, okay, of this picture. So we are going to visit this telescope right now. Okay, and from that from that place, we are going to understand better the history of ESO in Chile because La Silla was the first observatory that ESO placed in the Chilean Atacama Desert. Okay, so now we are going to visit the ESO 3.6 meter telescope in the background in order to understand better what happens there. Okay, so right now we are in the telescope. As you can see, it's very big. Um, Here we are inside of the ESO 3.6 meter telescope, or 360 or 360, as it's commonly called by the staff at La Silla. The name refers to the mirror diameter because it's 3.6 meters. Okay, so currently it hosts an exoplanet hunter, namely HARPS. Okay, a highly specialized instrument used every night to search for other worlds outside our solar system. So, what do you notice about the dome from the inside? It's huge. Okay, The altitude from the first floor to the dome is 25 meters. So all this structure of the telescope is equal to a 7-story building. So here you can see the dimensions, the size of the dome of this telescope. Okay, and in order to see how big is this place, everything seems small from here as compared with the telescope. So, for example, you can see a person in this picture there. Okay, so you can see how big is the telescope and the dome if you compare with a person. Okay, so the person, as I told you before, is a good reference to distinguish the telescope, okay, from the rest of the structure. So now you will see the telescope in detail. So we have three things we can see on a picture. I will show you now. You can see a picture. Okay, you can see a picture next to the telescope. Okay,
This is the
so
of the telescope.
sorry, say again. Sorry, Felipe, did you say something?
Sorry, is the up part of the up part of the telescope.
Yes, yes. So we are taking a look at the right side picture. So first, in dark blue, in that picture to your right, we find the structure supporting the telescope itself, namely the mounting. Okay, so this, okay, that's the mount of the telescope in the dark blue color. Okay, so um, the mounting works as a huge arm supporting the telescope and includes various systems that provide power, such as electricity. On this arm, parallel to the Earth rotation axis, the telescope moves to follow objects in the sky during observation. Now, going upwards, in lighter blue, we have the telescope's body, which holds the 3.6-meter or 360 centimeters main mirror and the secondary mirror. So again, this is the telescope itself. Okay, so we have the primary mirror here and the secondary mirror there. Okay, now where's the main mirror? It is not visible because it's covered by its protection system, the black structure there. Okay, but it's there. It's basically there. Um,
I
and in
have a
this
video
case,
of the 3.6 move.
sorry.
I have a little video of 3.6 move. Let me
Oh yeah,
show.
sure. So we can take a look at that
Let me show
of
them
the
the
telescope
video.
moving. Yes.
This is a
Yeah,
little
so that's
one.
yeah. Thank you, Felipe. That's how the telescope is moving, the 3.6 meters. Okay, so um, so in this case, as I told you before, the primary mirror is covered by the black structure, and this is a system of tabs which open and close to protect the mirror from dust or moisture while the telescope is at rest. So in the black tubular structure in the upper part, we have the secondary mirror, which gathers light from the main mirror in a beam and directs it to the instruments that analyze it. You will notice that the main mirror has a hole in the middle, so the light is sent to the instruments through it. And where is the instrument? Well, the instrument, in this case harps, is not visible because it's completely isolated in another room, or basically another floor of this building. So the 360 began operations in 1977. Okay, now we are taking a look at the process at the operations of HARPS. HARPS, as you can see in this picture, is detecting exoplanets using a technique called radial velocity. So basically, it's able to measure how the gravitational influence of an exoplanet can affect, let's say, the star. Okay, so the star can um, will show some kind of bouncing, and this will be reflected in the absorption lines in the spectra. Okay, so that is more or less what happens in this video you are looking at right now. Okay, the gravitational influence of an exoplanet in a star. Okay, so you can see the star um, uh, going approaching us and going far away from us. Okay, so this is what you're looking at the video. So as I told you before, the 360 began operations in 1977, and from the beginning, it represented a challenge for engineering and for ESO as an organization. So the European astronomy gathered talents from several countries to build an optical telescope in the 4-meter category, the largest and most advanced category that existed at the time. So why was such a large telescope needed? In astronomy, objects are analyzed through their light. So the more light we collect, the more we can learn. In this case, a bigger mirror will capture more light and therefore more information will be available. So we will be able to see fainter objects and smaller details. Okay. So a few moments ago, you was able to see how the 360 can move. Okay, so a mirror for astronomy, like the mirror of the 360, is not just any mirror, since its shape and surface must be perfect at the scale of fractions of thousands of millimeters. So to achieve this in the 1970s, an extremely thick mirror was manufactured, 53 centimeters thick on average. But this also implies an extremely heavy mirror. So the mirror weighs 11 tons, the equivalent of 2 African elephants. So if we want to build larger telescopes, we need to find other solutions. So how was the next steps taken? We will see it later with the NTT. Okay. Now, before going to the NTT, I think we have some time for questions about the telescope. So, Felipe, I don't know if we have
Y-
some questions so far.
Let me see a few questions. I see a few questions. I'm here. I got one. I'm located in rural Texas, where I do astronomy photography from of my backyard. Is La Silla Observatory facility ever available to amateur astronomer? The internet connectivity. Some amateur La Silla Observatory is a scientist observatory. So the only I believe the amateur astronomers is because in the sector of the La Silla have some positions to see the sky, but don't interrupt the principal observation of scientists' investigations.
Yeah,
In internet connectivity, don't have any connectivity to La Silla for amateurs because this is only for scientists, organizations, scientists investigation in La Silla. This is the
yeah. What Felipe is trying to say that
problem
is,
for amateur astronomers.
yeah, in the surroundings of La Silla, sometimes amateur astronomers can maybe, I don't know, bring a telescope or observe the skies, but the actual facilities of La Silla are not available for amateur astronomers because well, basically an amateur astronomer cannot use the NTT or the 360 because the only way to use those telescopes is to apply for telescope time, and this is a standard process only available for astronomers working at some scientific institutions. Okay? But amateur astronomers can probably visit some places in the surroundings of the mountain and also visit, of course, some amateur observatories near that area.
This is the only question I have. I invite to leave or questions, whatever you want, astronomy or about the telescope or ever you want to know about the astronomy of LAISO. Put your comment and then later in the guide to, in the virtual tour, I read you and answer is if it's possible. So let's continue to the next telescope, the modern telescope, the NTT, right?
Yes, yes. We are now going to continue, and we are moving to the next stop. We are going to the NTT. So the NTT is this telescope here. This is the this is an acronym for New Technology Telescope. Okay, so we are going to visit this one, and you will see the shape is a little bit different, and this is different in different aspects. Okay, so for example, I would like to highlight the difference between the domes. So the dome is different, the structure is different. So keep in mind that both telescopes have almost the same mirror diameter. Okay, but this dome and this structure is quite different. Okay, so the NTT was inaugurated in 1989. Okay, it's an old telescope. Okay, so it has a small and very compact octagonal dome with a system of flaps. This represented in its days an evolutionary leap in the construction of telescopes, since it allowed hosting instruments in smaller, lighter structures with improved airflow on the inside. So one were the more classical and massive domes, such as the 360. Okay, so this is the main difference here. So in fact, these flaps allow air to flow smoothly, reducing turbulence and preserving the sharpness of image. So do you remember the structure of the 360 telescope? Its huge dome and how small our colleague seem inside. In this case, the building is practically attached to the telescope, and if we stand in front of it, we will look approximately this size. The telescope mounting is also completely different. So here the entire building spins around 360 degrees. Okay, so we have this view. This is the front view of the telescope, and you can see that all is more compact here. Okay? It's a more compact shape. Okay. Now you can see the main mirror on a pale colored round structure. The disk is the mirror, and we can see that it reflects some light. So do you remember the 53 centimeters thick mirror of the 360? Well, the entity mirror has almost the same diameter as the 360, 3.58 meters to be precise, but it is significantly thinner. The mirror is only 24 centimeters thick. It is also much lighter, 6 tons, just one elephant. Okay? So, to keep perfect shape as the telescope moves, there is a system of actuators or pistons below the mirror. The system is enclosed inside the box that you see just below the mirror. Okay? Um, there are 75 actuators going up and down to keep perfect shape. So the system is computer controlled and is called active optics. Okay, so this is the name of the technology. Okay, working here now. Um, Active optics was developed by ESO and represented a significant technological breakthrough in the construction of the next generation of telescopes in the 10-meter category. Active optics has been applied to all large modern telescopes, including the Very Large Telescope, or VLT, at Paranal Observatory, and the upcoming Extremely Large Telescope, or ELT, currently being built near Paranal. Okay, so this is basically what happens here in this observatory. And now, something important also to mention is, of course, well, where's the staff? About 300 people work in La Silla, okay, on different telescopes and tasks. The scientific and technical staff work in the control room. Okay. Um, in this case, the control room of La Silla Observatory is located in a building quite far from here. So I think we have a video to show you how the control room looks like during the night. So Felipe, do we have a short video to show this?
Some question?
No, the video of the control room, please. Do you have the video?
Sorry, sorry, I understand because
The
some
control room, the video of the control room to take a
the
look at the people working.
let me show you. Here is.
Okay, now we have the video here. Okay, so at the left side we have the operations of the entity, and at the right side we have the operations at the 360. So this is a typical night. So we have the astronomers working there. And as you can see, we don't need a lot of people. We need, of course, astronomers and telescope operators, but we need people, of course, working at night. And this is how the control room looks like at night. Okay, so okay, during this time, now looking at the control room time lapse. I don't know, Felipe, if we have more questions about the telescope.
Let me see. We have a few questions more. The fear is there any apple to funding amateur astronomer to help with the cost of the telescope? It's becoming such expensive hobby these days. Yes, it's so expensive do astronomy, but the ESO don't have any funding for amateur astronomy to help the cost telescope. And sometimes the ESO do a special project to learn to teach of astronomy for astronomer to specialization for instrumenting or the observating in Alemania, in Germany, sorry, in Germany, and we don't have any way to funding on amateur astronomy for telescope. For the in occasionally the La Silla La Silla donating some telescope for example, in Chile, donating for University of Santa Maria, donating one telescope for teach about the instrumenting of the telescope. So don't have any much to for amateur astronomer, only for scientists. And the other question is, what is the URL to publicity accessible to La Silla Observatory archive of past feeds observatory files? The the page for looking of feeds is a ESO.org. This is the principal page of La Silla for looking for image for feed files or everything you know to about the astronomy of LISA.
Yeah, Felipe,
And the other
I think
question
I
is
can
in
provide
Spanish.
I think I can provide another link for that because maybe this person is asking about a very specific tool called Virtual Observatory. And in this case, well, ESO, not only La Silla, but ESO in general, has a virtual observatory link. I can put this link in the comment section. So basically, if you know how to browse in this information, you can do it, and you can take a look at the files of different instruments. Okay, but please be careful because those files are heavy, and you need to understand that you need to specify maybe the filter, the wavelength, exposure time, and many other technical parameters. But if you have the curiosity to search and you have the knowledge to understand these parameters, you can take a look at that web page. Okay, that's all.
The next
Yes.
part is about the of searching or research of astronomy. We have a top 10 of the principal research of la ESO, and let me show you a little show you the top 10. So you start.
Yeah.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang Theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
So I show you the ESO.org, the page. Recently, the research of astronomy is around in the run. So we have astronomers discovered disks around the star in another galaxy for the first time. It's a remarkable discovery. Astronomers have found a disk around a young star in the Large Magellanic Cloud. A galaxy named Boring Owls is the first time such a disk, identical to those forming planets in our Milky Way, has ever been found outside our galaxy. The new observation reveals a massive young star growing and accreting matter from surrounding and forming a rotating disk. Similarly for protostars, the detection was made using Atacama Large Millimetric or ALMA in Chile, in which the European Southern Observatory is a partner. This is one of the recent research, and the other old research we have in here in the page of the ESO point of org, and have a lot of information about to visit the, observ- the observatories of Paraná of La Silla and see the photographies of different part of us, telescope, stars, galaxy, all of you want. So I invite you to see the page, and you have a lot of information, whatever you want. So we have a different part of the astronomy, don't, not too technical, it's a beautiful part. So I will show you the night part of La Silla, right? And
Yes. Now
this
we
is
are going to take a look at something very interesting. So the tour goes on and night falls over La Silla. Okay, so there is no moon, so we can watch the night sky in all its splendor. So below, to the left of the NTT, we can see a very well-known constellation. Okay, uh, there. Okay, this one. So, what about this constellation? Um, okay, so does anyone recognize it? Well, it is Orion, the great hunter, with his characteristic belt, also known in Spanish as the Tres Marias. So tired, perhaps, after a long journey across the sky, Orion is ready to set over the western horizon. It is summer, or autumn. The hunter and the great dog that accompanies him, the Canis Major, have been following a particular path through the sky, the Milky Way, our galaxy. Our galaxy is really a huge flattened disk shaped as a spiral, but we see it as a band of light across the sky due to our viewpoint, since we are inside the disk. It consists of around 200 billion stars and huge clouds of interstellar gas and dust. Okay, so we can see the latter as dark clouds that cross the band of light. So the red clouds instead are made of hydrogen, the simplest and most plentiful element in the universe, from which stars are formed. Okay, so we can see that. Okay, we can see Sirius, the brightest star of the sky and the brightest star of Canis Major constellation. And here you can see the Milky Way. Okay, this area with more stars if you compare with the rest of the sky. So it's very, very beautiful, of course. So by looking through the Milky Way, we find two strange objects similar to clouds. In fact, these are the large and small Magellanic Clouds, and we can see those objects there. Okay, the large Magellanic Cloud and the small Magellanic Cloud, right there. Okay, so um, the Magellanic Clouds are our closest neighboring galaxies, and at the same time smaller than our Milky Way. They owe their name to the first written record of their observation, dating back to the time of the circumnavigation of the globe by Hernando de Magallanes, okay, or Ferdinand Magellan. So clearly, at that time, nobody knew what the galaxy was. Today, we know that galaxies are systems of hosting tens of billions of stars, and that these are classified as irregular due to their shape. So these typical objects of the southern sky also indicate the position of the south celestial pole, with which the apexes of an equilateral triangle are formed. Okay, so basically, if you take a look here, okay, more or less at this area, okay, we found something we call the south celestial pole. Okay, um, so but however, maybe the easiest way to locate the south celestial pole, since in this hemisphere we don't have the North Star, is using a constellation known as the Southern Cross. The Southern Cross is located there. Okay, I will show you close up there. That's the Southern Cross. Okay, so the Southern Cross is the smallest constellation, okay, of the official 88 constellations of the sky. Okay, and the trick here is to extend its major stick by about 4.5 times in the direction of the longer stick, and we will find the point around which the stars will seem to rotate in a clockwise direction from east to west. So we have to extend this the longer stick, okay, this one like 1, 2, 3, 4.5, and more or less like here, more or less approximately, we have the south celestial pole. Okay, okay. So in this case, you can also say that when you look at that direction, you are also looking at the south cardinal point. If you look at the horizon right here, you are looking at the south cardinal point. Okay, so this is useful in case you are lost in the middle of the desert. Okay. Okay, so if we continue exploring our Milky Way, this will take us back to the 360. So behind this, the center of our galaxy rises majestically, recognizable by its bulging shape and the prominent dark clouds surrounding it. Okay, so we have here the 360 and the Milky Way rising, okay, in the horizon. So its hearts contain a huge black hole, which has a mass 4 million times that of the Sun. On the left side, you can see through only slightly the colorful nebula and the dark filaments that surround the red supergiant star Antares. Okay, the brightest star in the constellation of Scorpius, an animal which put an end to Orion's life, according to mythology. The same gods of Olympus located them in the polar opposite of the celestial sphere. Okay, so here we have Antares, okay, this one. Okay, so now we are going to take the last information from here. If we now look at this region of the sky with the eyes of the native communities of the Andes, we will not look at the brightest star, but at the shape of the impressive dark clouds, most notably the great Gamma. Okay, its eye being the star Alpha Centauri. So we have here the Gamma. Okay, and this is Alpha Centauri. Okay, Alpha and Beta Centauri. Okay, so it's interesting to take a look at this different shape or different interpretation of the dark sky, of course. Okay. In fact, Alpha Centauri is actually three stars, but we see them as only one with the naked eye, and this is the closest star to our sun. Now, you might wonder about the fascinating colors of this picture. They are real, of course, but then why do we see the sky in black and white? Because our color receptors, the cones in our eyes, cannot perceive very low light intensities, such as those of the night sky. However, in a camera, we can leave the shutter open and use a long exposure time to collect light. Okay, so in this way, with careful processing, we can decipher colors. Okay. Okay, so now let's relax and we are going to visit the hotel of La Silla Observatory. Okay, so we are going to um, change the view. Okay, and also maybe it's important to mention before going that from this view, from this perspective of the 360, we can see there in the background the light pollution of La Serena. Okay, so this is an important problem for astronomy. We have to keep in control the light pollution because, of course, this can affect astronomical observations. So at this moment, we have to try to keep this under control. In this case, this is the area of uh, looking at the Coquimbo, La Serena, and when we look at the opposite direction, we have Vallenar here, and this is the road, the main road. Okay, so this is why we have to be careful about light pollution. Okay, okay. So now we are going to move. We are going to move to another location. Let me move, and I will show you. Well, this is like the road, as you can see. We are approaching the hotel or of La Silla, but we are taking this. Well, the people who wants to go from the 360 to the hotel is taking this road, and we can see several telescopes of La Silla. Some of them in operations, some of them not in operations. But you can see that we have a huge amount of a big amount of telescopes here. Um, and of course, this is a very old facility, but it's very famous. It's an icon for ESO. Okay, so now we are going to La Silla Hotel here.
We have last questions for people
Yes,
viewing. The one
yes.
is a recent gamma ray burst detected in 2022 was detected measuring La Silla, and the Tarot is a game ray burst telescope for I don't know is detected in precisely in La Silla. And the next question is, Hunt, when does gamma ray burst origins and what is the risk we face in future massive bursts? In future massive bursts. Continue
Yeah,
when does the gamma ray
Felipe,
burst
maybe I
origins?
can I can answer something about this regarding the gamma ray burst detected in 2022. Well, it was first detected by the NASA's Fermi Gamma Ray Space Telescope, and as far as I know, some of the follow-ups of this discovery, yeah, was possible from La Silla, specifically from the 2.2 meter telescope. This is one of the telescopes in operation at La Silla. So it was not discovered from La Silla, but the follow-up observations were possible from La Silla. And as far as I know, there is no risk actually for future massive bursts. It's only a good opportunity to take a look at those bursts, but you have to do it with very fast telescopes because they are very, let's say, short events. So you need a very specific telescope to observe that.
And the last, and I know the answer, but how do you get the payroll to analyze deep files photos? Deep files, payrolls. I don't know. The only way to get a deep field photos is in the page of the ESO point of org. You can share some deep space photos, and this is we have.
Uh,
This is the all the question we have today. So
yeah,
this is the
yeah,
last part.
yes, yes. This is the last part. So yeah, well, and this is the last picture. In this picture, well, this person is a photographer of some of the pictures you saw before, and this is like the backyard of the hotel at La Silla. You can see it's a very nice place with all the necessary facilities for the people working here, and you can see that this picture was taken in a very beautiful night with the Milky Way just above the hotel. So this is a typical night from La Silla. Okay. Okay, so we are finishing this experience now. The hotel, just to let you know, is the place where the observatory's staff take a rest and spend some time until the working shift starts. Okay, so just to finish now, I would like to remind you that these visits, information, image, and material are available on the ESO website. Okay, so just in case you want to visit. Okay, now I hope you enjoy this virtual experience and please pay attention to the ESO social networks to take a look at when will be the next virtual tour. Okay, so we hope you enjoy the tour, and on behalf of ESO, we thank you very much for joining us and see you soon.
Thank you and see you later.